Hey, welcome back. This is Charlie Thompson, and this is probably going to be the shortest video, the shortest how-to video you're going to see all semester. This is how to calculate rates of movement for the Plate Tectonics Lab, Lab 12. So we're going to do some math. We're going to calculate rates of movement along the plate boundaries. We want the answer to be in centimeters of movement per year. And the easiest way to do that is to measure the length in centimeters. So when you're in Google Earth, as you're doing these measurements, you can select the units, as I mentioned. So just make sure that the units are set to centimeters. You could have picked meters, could have picked whatever. Just make sure it's in centimeters. The age is given in millions of years for all of the Hawaiian Islands. The ages for all of those are in years. And when we get to the San Andreas Fault, the age there is just given in years. But it'll all work out. So we're going to calculate rates of movement. What we're dividing distance, the distance moved in centimeters, dividing that by time in millions of years or in years. So in the earlier demonstration, we measured 32,166,016 centimeters from Kinmai to Abbott. The numbers that we end up with for movement aren't going to be accurate because we're taking a measurement from the Emperor Seamount chain. We're starting on the Emperor Seamount chain and we're ending up on the Hawaiian Island chain. So it's good as an example of how to measure, but I wouldn't use the answer for anything. So we've got the distance, 32 million centimeters. We know that the Kinmai Seamount is 47.9 million years old. Abbott Seamount is 38.7 million years old. So the difference between them is 9.2 million years. So now we're able to put this into a formula. We know that the plate moved 32.2 million centimeters in 9.2 million years. Right, so we've got millions of centimeters and millions of years. Later, we're just going to have centimeters and years. So the number is expressed in millions of centimeters. This number is expressed in millions of years. So the millions cancel out and you just get centimeters per year. When you do the San Andreas Fault measurements, the distances are just going to be in centimeters, but the age is just going to be years because it's only like 3,700 years old. So it's just going to be centimeters to years, so there's no different units. Back to the Hawaiian examples. The plate moved 32.2 million centimeters, 9.2 million years. So 32.2 divided by 9.2 is 3.5 centimeters per year. So I would like everything, this one, crazy math. 3.5 was exact. I didn't have to round. But I want you to round all of the speed of plate movement numbers, round those to one decimal place. So this is going to be 3.5 centimeters per year. And that's it. If you have questions on anything, please let me know as soon as possible so that you can get back to work. And I hope you enjoy this lab.